Welcome to today's lesson, to which I'll be looking at what? Sound. Say sound, sound. We looked at sound and light as a form of energy, is it not? Yes. What is sound? Sound are the things that can be heard, is it not? Yes. How do we hear sound? We hear sound because sound are vibrations. Say vibrations. Sound is what you hear when matter vibrates or move. So without a vibration, you cannot get sound. Take a look at my friend at my right. He's clapping. As he's clapping, he's sending some vibrations which are carried by a medium such as air. Okay? When this happens, the result is what we call what? Sound. So vibrations carried with a material produces sound. And where these materials are carried, we say they are in sound wave. Sound also travels in water. It travels in steel. In fact, it will interest you to know that sound travels fastest in steel and slowest in air. So the speed of sound is fastest in steel, followed by water, before you now see what? Air. Is it not? So sound wave will spread out and lose their strength as they what? Travel. The more the sound travel, the lesser you hear it. Do you get it now? Yes. Let's look at some properties of what? Sound or sound waves. Okay, look at this model I have here. I drop a stone into the water. You will see a ripple spreading out to all sides. Is it not? Yes, you see it. You have done this many times. Is it not? Let's picture this as a sound. This is the same thing that happens when you speak or you create sound. It vibrates and moves through a medium or material medium such as the air, water, and steel. Alright? And as it does that, at some point, as it gets further, it disappears or diminishes. You cannot hear it again. So sound wave have certain properties that we use to describe them. To describe sound wave, we use certain properties to describe them. Some of the properties are your wavelength, your frequency, your amplitude, and your speed. These are some of the properties we use. Now, what is speed? What is wavelength? What is amplitude? Uncle? Let's look at them a little. This is a sign representation of what? Sound. This is how sound is represented. Okay. The highest part of the sound, which is the top of this blue circle up and down, we call it the up one. We call the crest or the peak. Okay. While the down one we call the trough. All right. Now the peak, normally peak means the highest point of anything. Okay, P-E-A-K. Now the peak, you can see the arrow that is drawn here under the wavelength. Can you see it? Yes. If I take the peak of one wavelength and I take the peak of another wave, it gives me the wavelength. I take it again. If I take the peak of one wave and the peak of another wave, it gives me the what? Wavelength. So we define the wavelength of the sound wave as the distance from the peak of one wave to the peak of another wave or another successive wave. So it's the distance between the peak of two successive wave, okay, or the distance between two crests. All right. Yes. Then we look at frequency. Frequency is simply the number of wave that is produced in 1 second. You get it now? The number of wave that is produced in 1 second. The amplitude simply means the distance that a wave travel. Okay, look at the wave. You can see it has different amplitude. For the first one, the second one, the third one, they have the same amplitude. While the fourth one, fifth one, and sixth one have different what? Amplitude. What is the amplitude I'm describing? Can you see this black line here? Yes, the black line at the middle. The distance between the black line and the up is what we call the amplitude, okay? So the distance the wave travels is called the what? The amplitude. Do you get it now? Then we look at the speed of a wave. The speed of a wave, simply how fast the wave is. To know the speed of a wave, we'll multiply the wavelength and the frequency. So if I multiply the frequency of a wave, let me say the frequency is 12 and the wavelength is 2. 12 times 2 will give me the speed of the wave. Do you get it now? Yes, give me the speed of the wave. You have been in an empty room before, is it not? When you speak in an empty room, what do you observe? The sound echoes back to you, is it not? Yes, we call it echo. True or false? True. So echo. Echo is a property of sound or sound waves. Okay? When sound wave echo, what actually is taking place is called reflection. It is returning the sound back to you because the walls around are bouncing the sound or returning the sound back to you. So one property of sound is a reflection. Not only that, sound can also be absorbed. Now imagine you are in a room that has foam, that has a chair, that have curtains. If you speak, do you hear echo? No. Why? Because the materials inside that room absorb or retain or collect the sound, so it cannot bounce back to you. So sound can be absorbed and sound can be what? Reflected. That is what you must know as property of what? Sound. Another thing about the sound absorption and reflection is that some materials that do not allow sound to pass through them, we call them what? Soundproof. What do? They absorb the sound. So soundproof material such as your foam, okay, your ear foam. I'm talking about ear. No, I didn't say earpiece. So ear foam, the one we put on our ear to avoid noise in an industrial area. All those are examples of soundproof material. Okay, they don't allow sound to pass through. They absorb all the sound. All right. So sound wave can also be what? Modified. You can make it loud or soft. All right. So decreasing the intensity of sound, for example, you could whisper or yell. When you whisper hello to a friend, the sound will have what? A low amplitude, you know. But when you hear, like you shout, the sound will have a high what? Amplitude. So you can think of the amplitude as what? Volume. We are increasing your volume, you are reducing your volume, you are doing what we call what? Amplitude. Okay, what other thing we notice? You can also change the pitch of a sound. What is the pitch of a sound? Pitch of a sound is simply how high or low sound can be. It's quite different from volume. Volume is the loudness or softness. Okay, a high note will give a high pitch sound, and a low note will give a low pitch sound. Generally, we have pitch to be high, medium, and what? Low. Okay, a faster vibration, once the vibration is occurring at a faster rate, it gives what? A high pitch. Have you ever heard a motor siren or a police siren or a medical siren? That is an example of what? A high pitch sound. Okay, why other ones that are medium, that are not too fast, not too slow, we give a medium pitch sound, and then a slow one we give what? A low pitch sound. We can analyze this using the C key of your what? Keyboard. Now your keyboard, you know the keyboard are arranged in black and white, and the keys are what? Constantly what? Repeated from left to right, is it not? Look at your first C key. Now the C note played on octave lower, we have what? A lower pitch. Why if I play it on the medium scale, it will have what? A medium pitch. If I play it on the high note side, it will have what? A high pitch. But it is the same what? C key. True or false? It is the same C key. That tells you that higher pitch notes have higher frequencies than lower pitch notes. So this is the representation of what? How the wavelength used to look like. Okay, a low pitch sound will have a large wavelength. Why? Because it's taking time to move. Do you get it now? A medium pitch sound will have a medium wavelength because it's taking less time to what? Move. But look at the high pitch sound. The wavelength, remember I told you that wavelength is the distance between two peaks. Okay, two successive peaks. Can you see how close they are to each other? And can you see how fast they are? Do you see it now? So the high pitch will have what? Small wavelengths that are moving what? very, very what? Fast. Sound does travel at different speeds through different forms of what? Matter. Sound travel fastest through solid, like steel, then liquid, and then slowest through what? Gases such as what? Air. I've said this before, is it not? Furthermore, the temperature of air can affect the speed of what? Sound. Is it not? Generally, sound slows down. Generally, sound slows down in cool air and speeds up in warm air. Alright? What am I saying here? Without air, without steel, without water, you will not hear sound. Remember Robot Boy I taught you about, is it not? That place a ticking clock inside a glass jar. You don't hear it. Why? Because there is no air inside the glass jar to carry the sound to your what? Ear. That is how it is in space. Remember in space there is no air, is it not? Yes, there is no air. So we cannot hear sound. The wind can also have an effect on the sound. If you are outside a windy day and trying to have what? A conversation with a friend, your sound is determined by the way you are speaking. If you are speaking to the air will carry the sound away, is it not? You will not hear anything. But you are speaking in the parts that the air is moving. Let's say you are speaking to the right and the air is moving to the right. It will easily carry your sound to the other person's ear. Do you get it now? That is how the wind affects sound. Alright? So like I said, in space there is no air. You can see the air in this material is being sucked off to space. Why? Because in space there is no air. And some sources of sound. Where do we get sound from? One place we get sound from is what? The human voice. Is it not? Vocal cord is responsible for what? Our voicing. Okay? There are basically two thin flaps of what? Skin that run parallel to one another. Okay? And it's located in what? In the trachea of our what? System. What do? They carry air through and out of what? The lungs. So when they allow air to pass, that is what creates the voice. As I'm talking to you now, my vocal cord is allowing air to pass through and what? Come out. Okay? So the way air passes through determine the kind of pitch you produce. You get it again? That takes us again to the word, the kind of tone you what? Produce. Alright? Now, musical instruments are what? Probably the most common items associated with what? Sound. Musical instrument is another form of what? Sound, is it not? Yes. You know we have so many kinds of what? Musical instruments that are grouped into different classes, is it not? You have your woodwind, you have your percussion, is it not? And then you have your, what is it called? Your brass instrument and all those classes of what? Instrument. All of them produce sound. And this sound are what? Plays into the ear. That's why we call them musical instruments, okay? Other sources of sound are your stereos and what? Televisions, okay? There are two sources of sound that we are familiar with, you know. These are great examples of the distance that sound is what capable of traveling with. TV and radio sound is created in a studio where it is recorded using high technological equipment, okay? The sound now travel through your radio or television set using electrical what? Energies. Is it not? You can see my TV and my radio there. Is it not? Power lines as well as satellite signals work together to transmit the sound from the studio to your home. So the mechanism in the stereo of television that is responsible for creating sound is called speaker. Alright? It is your speaker that produces the sound. After all the transmission and everything, if there's no speaker, you will not get sound, okay? The speaker uses mechanism such as your magnetic and electric field to combine or convert electrical signals into what? Sound. You get it now? Other sources of sound include the things that we hear on a daily basis. For example, the sound of your car engine. Okay? When they are driving, you have your refrigerator that is running, you have birds that are what? Chirping, and then you have the sound of trains passing by. Okay? They also have the sound of children playing in the schoolyard, and then sounds of airplane passing over what? Your head, is it not? All these are other sources of what? Sound. You get it now? Yes. Let's look at light and sound in the environment. Okay? Light and sound, we can see that they are very, very what? Important to us in the environment. Imagine there is no light, there is no sound. There will be total what? Confusion, because we cannot hear each other and we cannot see what? Each other. That tells you the extent to which light and sound are what? Important. But as important as they are, they also have a negative effect on what? The environment. Okay, that is it. Look at this first scenario now. We invented what? MP3 players, is it not? Why? MP3 player is very good. Why? Because you use it to listen to music. You must not wait for, what is it called, NEPA to give you light. You must not wait for electricity. You can just charge it and then use it to play what? Music, and it's pleasing to your ear because you use what? Earset or earpiece. Is it not? Yes, that is the advantage of it. But the disadvantage of it now, or the negative part of it, is that somebody might be going along the way and put two earpiece on his ear and is crossing the road, or is riding a bicycle. He will not be able to hear the noise of car, and it will result to what? Accident. Do you see the disadvantage of it now? Yes. So it is very important that even as inventions are taking place, we should try as much as possible to reduce the way we use them. Okay, take for example, today they will tell you Infinix this is available. Before you finish using Infinix this, another one is out again, another one is out again. People no longer use what? Box television, is it not? They no longer use black and white television. They no longer use, everybody is using plasma now. Some people are no longer using plasma now, they're not using flat smart TV. What happens to those old ones? Where do we take them to? Do we recycle them? No. They are creating junk everywhere in the world, society. They are polluting the world, environment. Is it not? Yes. So as they are creating more technologies, they have negative advantage and positive what? Advantage. But we have to try as much as possible to reduce the what? Negative advantage. Look at another example. Street lights were created to brighten up the city street, is it not? And surrounding area for what? Cars and what? Pedestrian. Pedestrian are passers by, people passing by the roadside are called what? Pedestrian. Okay, why this is beneficial in most cases, why it is very good to have street lights in most cases? There are areas that do not require what? Constant light, and as such we are wasting or using energy carelessly and wasting what? Resources. Although this one is not applicable to Nigeria, all right, because Nigeria, we don't have enough power, is it not? Yes. But in countries that are developed, there are some areas that do not really require light, but they just put on the light and then they are wasting that energy. Do you get it? Yes. So while light is good, as I said earlier, it's very important for us to what? Know what to do. Now I want you to settle down with this video and watch and know more about sound. Take note of their property, take note of their medium in which they transfer, take note of sound waves. Okay,
every sound is produced by a vibration. Vibration is the back and forth movement of an object. As you speak, vibrations are produced by the vocal cords in the throat. You can hear only when the sound energy reaches your ears. But how does sound energy travel? Wonder how that works? Come, let's go across to Dr. Zook. Sound energy travels in the form of sound waves. There are mainly two types of waves: transverse wave and longitudinal wave. Let us see how waves travel. We can use a slinky spring to observe both types of waves. Emily is holding one side of the slinky, while Dr. Zook is holding the other end. With a quick upward flick of the wrist, Dr. Zook has sent energy traveling through the slinky. Notice how the slinky moves? This is a transverse wave. In a transverse wave, the particles vibrate at a right angle to the direction of the wave. The wave traveled from Dr. Zook to Emily and back. Now let's see what a longitudinal wave looks like. Emily is holding one end of the slinky, while Dr. Zook is pulling its other end towards himself and then pushing it towards Emily. Watch closely, and you will notice that some of the coils crowd close together and then slowly move farther apart. This is because the vibrations are parallel to the direction of the wave. If the wave moves from right to left, then the particles also vibrate from right to left. This is a longitudinal wave. Sound waves are longitudinal waves. These waves travel at different speeds in different mediums. The medium could be a solid, liquid, or gas. Now let's see how this works. In a solid, the particles are very close together. Sound energy moves as one particle hits the other particle. With the particles being so close together, sound travels quickest through a solid. If we look at particles in a liquid, they appear to be slightly further apart when compared to solid. Thus, sound energy takes a little longer to travel through a liquid. Look at the particles of gas. They are spread out, and hence, sound waves travel most slowly through them. Now we know how sound travels in different media. The vibration of particles produces waves. Wavelength is the distance between two consecutive compressions or rarefactions. The number of waves passing through a point in a second is called frequency, and it is measured in hertz. Sound waves travel in all directions.
Emily?
Sound gets reflected. That is, it bounces back on hitting a solid surface. Bouncing back of sound is called echo. Bouncing back of sound is purposefully used in detecting depth of seabeds. That's amazing, isn't it?
Welcome back from that video. I believe from this topic you now know that sound is a form of energy. You now know that sound, when it travels in a medium such as air, steel, and water, we call them sound wave. And then you now know that there are different sources of sound. Okay, and then you also know some of the properties of sound. That sound can be reflected, absorbed, and then you can also change the pitch and the amplitude of what sound. You now know that sound is a longitudinal wave. Okay, we hear sound as a result of what? Vibrations of sound materials. If a sound material does not vibrate or matter does not vibrate, we cannot hear sound. You are hearing me because my mouth is vibrating. You are hearing my clap because my hands are what? Vibrating. You get it now? Yes, that now brings us to the end of the lesson. I want you to do the other activities in this lesson and stay safe. See you in next class.